Download this code from codegive.com, link in the description below. Generative AI Fine-Tuning of LLMs, a crash course. Fine-tuning language models, LLMs, can significantly enhance their performance on specific tasks or domains. This crash course will guide you through the basics of fine-tuning a generative AI model, particularly using the Hugging Face Transformers library. Prerequisites: 1. Python knowledge, basic understanding of Python programming. 2. Familiarity with machine learning, basic concepts of machine learning and neural networks. 3. Installed packages: transformers, datasets, torch, or TensorFlow, pandas. You can install the necessary libraries using pip, bash. Pip install transformers, datasets, torch, pandas. Overview of fine-tuning. Fine-tuning involves taking a pre-trained model and training it further on a smaller, task-specific dataset. This process allows the model to adapt to the nuances of the new data while leveraging the knowledge it gained during pre-training. Step 1. Choose a pre-trained model. Hugging Face provides a variety of pre-trained models. For this tutorial, we will use the GPT-2 model. Step 2. Prepare your dataset. You will need a dataset that is relevant to your task. For the sake of this tutorial, let's create a simple text dataset. Python. Import pandas as PD. Sample dataset. Data equals text. The sky is blue. The sun is bright. The grass is green. The ocean is deep. df equals pd data frame, data. df.to_csv, dataset.csv, index equals false. Step 3, load and pre-process the dataset. Using the datasets library, we can load our dataset and pre-process it. Python. From datasets import load_dataset. Load the dataset. Dataset equals load_dataset, CSV, data_files equals dataset.csv. Pre-process the dataset. Def preprocess_function, examples. Return input_ids, tokenizer, examples text, truncation equals true, padding equals true. Load the tokenizer. From transformers import GPT-2 tokenizer. Tokenizer equals GPT-2 tokenizer. From pre-trained, GPT-2. Tokenized datasets equals dataset.map, preprocess function, batched equals true. Step 4, load the pre-trained model. Next, we load the pre-trained GPT-2 model. Python. From transformers import GPT-2 LM head model. Load the pre-trained model. Model equals GPT-2 LM head model. From pre-trained, GPT-2. Step 5, fine-tune the model. Now, we set up the training parameters and start the fine-tuning process. Python. From transformers import trainer, training arguments. Set training arguments. Training_args equals training arguments. Output_dir equals /results. Evaluation_strategy equals epoch. Learning_rate equals 2e5. Weight_decay equals 0.01. Per_device_train_batch_size equals 2. Number_train_epochs equals 3. Create trainer. Trainer equals trainer. Model equals model. Args equals training_args. Train_dataset equals tokenized_dataset strain. Fine-tune the model. Trainer.train. Step 6, save the fine-tuned model. After training, you can save the model and tokenizer for later use. Python. Model.save_pretrained, fine_tuned_model. Tokenizer.save_pretrained, fine_tuned_model. Step 7, generate text with the fine-tuned model. Now you can use your fine-tuned model to generate text. Python. Load the fine-tuned model and tokenizer. Fine_tuned_model equals GPT-2 head model.from_pretrained, fine_tuned_model. Fine_tuned_tokenizer equals GPT-2 tokenizer.from_pretrained, fine_tuned_model. Generate text. Input_text equals the ocean is. Input_ids equals fine_tuned_tokenizer.encode, input_text, return_tensors equals pt. Generate. Output equals fine_tuned_model.generate, input_ids, max_length equals 50. Print, fine_tuned_tokenizer.decode, output 0, skip_special_tokens equals true. Conclusion. You have successfully fine-tuned a generative language model using Hugging Face's Transformers library. This crash course provided you with a basic understanding of how to prepare data, fine-tune a model, and generate text with it. Further considerations. 1. Data quality. The quality of your dataset significantly impacts the performance of your model. 2. Hyperparameter tuning. Experiment with different learning rates, batch sizes, and epochs. 3. Evaluation. Always evaluate your model on a separate validation set to assess its performance. By exploring these aspects, you can enhance your fine-tuning process and achieve better results for your specific applications. Happy coding!